Hi guys, this is a video key for the Geometry Concept Check 3.5 Part B or Version B. So I'm just going to go over and explain how to get each of the parts. So for the first one it says find x so that n is parallel to p. So if we want n to be parallel to p, we need to prove one of four things. Corresponding angles are congruent, alternate interior angles are congruent, alternate exterior angles are congruent, or consecutive interior angles are supplementary. If we can prove any of those things, then that would mean that n is parallel to p. So what angles are we talking about? We are talking about angles 8 and 11. So right here, those are alternate interior angles. No matter what, regardless if n and p are parallel or not, these are alternate interior angles. So if we can make them congruent, so we were given two angle measures for both of them, two expressions. If we can make them congruent, then that would mean that n is parallel to p. So we're just going to say we're going to make them congruent. So this is not required, but we want, I'm just going to write down, we want, let's focus here, angle 8 congruent to angle 11. And so that means we want the measures to be equal. So measure of angle 8 equal to the measure of angle 11. And then so we're just going to set them equal. So I'm going to do 12x minus 6 is equal to 20x minus 102. So I'm going to figure out what x value will make those two measures equal, which means the angles are congruent, which means that the lines are parallel. So this is just a really easy linear equation to solve. So 8x minus 102, and this is a negative 6. And then we're going to add 102 to both sides. And so that would be 96 is equal to 8x. And then you divide each side by 8, which I believe is 12. I'm just going to check my math just to be sure. 12 times 8. Yep. So x is equal to 12. So that's what x has to be in order for measure 8 and measure 11 to be, measure of angle 8 and the measure of angle 11 to be equal, which means they're congruent, which means n is parallel to p. Okay, for problem 2, same idea here with some different angles and different lines. So we want L and M to be parallel. So we're talking about measures of angles 14 and 15. So those are same side interior angles. Again, no matter what, they're same side interior or consecutive interior. So if we can show that they're supplementary, then that would mean that L and M are parallel. Okay, so our transversal in this case is P. So we want them to be supplementary. So I'm not going to write that out this time, but we want the measure of angle 14 plus the measure of angle 15 to equal 180. So we're just going to substitute those values there. So we're going to get 12x minus 30 plus 28x minus 110 equal to 180, and then we just solve from there. So combine like terms on the left side, that would be 40x, and then negative 30 plus negative 110 is negative 140 equal to 180. Add 140 to both sides. I should have talked about up here, you can easily check your answer by plugging back in x and making sure you get the same thing. So 12 times 12 is 144. 144 minus 6 is 138. And then 20 times 12 is 240, and then 240 minus 102 is also 138. So that works. So I'll check my answer on this one. So 180 plus 140 is 320. Equal to 40x. Divide by 40. X is equal to 8. And we can check again just to make sure this works. So 12 times our 8, which is our x, is 96, and 96 minus 30 gives us 66 for that angle right there, and so we want this angle to be supplementary. So we do 28 times our x, so 28 times 8 is 224 minus 110 is 114, and then 114 plus 66 is indeed 180. So we are correct. So we want x equal to 8. That will make a measure of angle 14 and measure of angle 15 supplementary, and so that would mean same side interior angles are supplementary, which by the same side interior theorem converse makes L and M perpendicular, or L and M parallel. All right, moving on. Use the figure above to determine which lines, if any, are parallel. State the postular theorem that justifies your answer. Okay, so if I know this, if I know that the measure of angle 2 plus the measure of angle 3 is 180, that means angle 2 and angle 3 are supplementary. Does that tell me that any of those lines are parallel? So let's go up and look at where angle 2 and 3 are. So here's angle 2 and here's angle 3. They're same side interior angles, and they're supplementary. So if same side interior angles are supplementary, then the lines are parallel. So I can tell that L and M, because those are the two lines that help form these angles, and this N, line N, is the transversal. I know that L is parallel to M. Okay? And what I can cite is the consecutive or same side interior converse. So I should say converse of. I was going to put it at the end, but let's put it at the beginning. The converse of the consecutive interior angle theorem. Or same side interior angle theorem, because we were given a same side interior angle supplementary, so we can conclude parallel lines. Let's move on to the next one. So angle 9 and angle 11. Okay, so 9 and 11 would be right here. Here's 9, here's 11. Okay, those are corresponding angles no matter what. So if we can prove that they're congruent, we can get some parallel lines. And they told us that they're congruent. So since I've got, I'm just writing this for a note, corresponding angles, and they're congruent, then by the converse of the corresponding angles postulate, we've got some parallel lines. So what are those parallel lines? We can see they're L and M again, and P is playing the role of the transversal here. So we know that lines L and M are parallel. L is parallel to M by the converse. So again, we're concluding parallel lines, so it's the converse of the corresponding angles postulate. Okay. Number 5, last one for this section, angle 5 and angle 10. Angle 5 is here. Angle 10 is here. Okay. Those are alternate interior angles. Okay, so since I'm also told that these alternate interior angles are congruent, then I'm going to be able to conclude some parallel lines. So alternate interior angles congruent, so I know the two lines that form them, not the transversal, but the other two lines must be parallel. So here that tells me that N is parallel to P, and I'm going to cite the converse of the alternate interior angles theorem. Okay, and that's it for those 3 problems. Now we're going to move on to the proof here. So we actually did this in our notes, but we're proving the consecutive interior angles theorem. So we can only use a postulate to help us out. So we're trying to show that if consecutive interior angles are supplementary, that those lines are parallel. So we're trying to prove that theorem, the converse of that theorem, the converse theorem. So we can only use the converse of the corresponding angles postulate. Okay. So if these are supplementary, okay, so we're going to do angle 1, angle 2 are supplementary, and that's our given. Okay, we also know some other things. I can see that angle 1 and 3 form a linear pair. So remember, you can't jump to straight that they are supplementary. You have to say are a linear pair. And that's by the definition of a linear pair. Now that I know they're a linear pair, by the supplement theorem, I can say angle 1 and angle 3 are supplementary. Now, it would be the same thing as if you said the measure of angle 1 plus the measure of angle 3 equals 180. But we want to use the congruent supplement theorem here in a minute, so just say that they're supplementary. We don't want to say that other thing. We want it to say are supplementary, not the equation. Okay, and that's the supplement theorem. Now, if angle 1 is supplementary with angle 3 and angle 1 is supplementary with angle 2, then by the congruent supplement theorem, angles 2 and 3 must be congruent. So I'm going to conclude that angle 2 is congruent to angle 3 by the congruent supplement theorem. And now that I've shown that angle 3 is congruent to angle 2, those are corresponding angles. If corresponding angles were congruent, then lines parallel. So I can go ahead and conclude that line L is parallel to line M by the converse of the corresponding angles postulate. That's the only one. You can only use the postulates in the proofs of these theorems, because this hasn't been proven in general, but these can be proven based off of the postulate. And that's it for your proof. All right, now for the construction. So I saw a lot of you just automatically do perpendicular. It says parallel, people, okay? So we're constructing a parallel line. So you have to do the copying an angle construction. So we're gonna copy an angle. So we're gonna make corresponding angles congruent, which means our lines are parallel. So to do that, we first have to have an angle, which there's no angle here yet. So you can draw your transversal any way you want. I'm going to draw my transversal this way. So like that, okay? And if you can see, it didn't really go exactly through the middle of the circle, even though it's not supposed to mention through the middle of the dot. So I'm always going to go on the line. All right, so then here's my angle. So what I want to do is I can pick any of these angles. It doesn't matter which one. I always think this one's the easiest. So we're going to copy this angle up here, because if I can get this same exact angle up here, then draw that line, then those lines are going to be parallel, okay? So the first thing you have to do is put your point of your compass on the vertex of the angle, so right here, exactly where those two lines intersect. And then you're just going to make an arc. Okay, so obviously my angle is not this full arc, it's only from here to here, so that's part of what we've got to work with. So I'm going to pick up the point and then put it on the vertex of my angle, my new angle. I'm trying to copy it here, so I want that to be the vertex. And so you want to make another arc that's at least as big as this one. And notice if it didn't hit here, you would need to extend your line. So make sure that your arc isn't too big that it's going to go past. I was close there, so I need to be careful. Okay, now pick it up. Now the next part you're going to do is we're going to measure from here to here and then do that here. So we could get the same like width, quote unquote width of the angle. So remember, this is the part where you're going to have to be careful and just make sure that you are being as precise as you can. So I'm going to put the point here. You really could put the point here too, it doesn't matter. But when you come up here, you obviously have to put the point here because you don't know where it is over here. So I'm going to make sure that it's going to work by just trying to do little arcs. Just make sure it hits where I want it to hit. So that's a little too far off. Just a little bit. And that's pretty good, right on that intersection. Okay, so I've got that distance there. Picking it up, putting the point here again, and then an arc there. So see how that gives that same width here. And then when I draw a line between this point and this point, it should be parallel to line L. I'm actually going to use a pencil to draw this. Okay, so we'll see how good this is. Okay. All right. So I'm going to aim for that where I feel the point here. And then the intersection. And then once you draw this nice line, you should have a pair of parallel lines. There. All right, let's zoom out here and see what we got. Okay, so we have a pair of parallel lines. So we want to mark their parallel. So I've shown that, hey, look, I've got corresponding angles congruent. Therefore, these lines must be parallel. So I'm going to mark them as parallel. And that's it for your parallel line construction. All right, and the last one is doing the distance between A and BC. So notice, remember that distance has to be perpendicular. So there's no way I can draw a line from A to this part, the segment BC, and be perpendicular. There's no way. And it says to line BC. So And this will happen when we do altitudes and triangles too. It's not always going to hit right on the segment. You have to extend the line, okay? So there I extended my line. And now we're just going to do the perpendicular construction. So you put the point of your compass there, and notice, my width is not big enough because it's got to hit this line that you're trying to get perpendicular to. Draw a line perpendicular to, it has to hit it twice. So make sure it's big enough to do that. And then you get your 2 arcs, okay? And then you can keep it the same width if you want, as long as from the 2 arc intersections in the line, it's at least half. So mine's definitely at least half. But you don't want to go off the paper either, so you just got to be careful. I should be fine to leave mine at the same width. And normally when we do this, we would do like above and below. If the point was on the line, we'd go arc above, arc below. But we're just going to do the arcs over here because we're forcing it to go through A. So then we're going to point the compass on the other arc intersection and get that. Oh, I was close here. So just make sure your arcs are big enough to get that intersection. Pick up your pencil, and then you're just going to draw a line from A to that arc intersection, because that will be the line that's parallel to, or sorry, perpendicular to BC and goes through point A. And you only want to do a solid line from A to BC because that's going to be, or line BC because that's the actual distance. And I'm going to do a dashed line everywhere else. Solid from here to here, and then I'm going to continue just with a dashed line, okay? And then we want to mark it up. Okay, so we need to mark it up and name the distance. So right here it says name the distance. So I'm going to call that point D, and I'm going to put a right angle on there. Okay, so the distance from A to line BC, oops, line BC is AD. So we're not actually measuring it, excuse me, but we are naming it. And you do not put a line over the top because that's a segment. This is a distance. This is a distance because this represents a number. So it's 80, that's that distance. So to get credit for this problem, you have to show all of these markings. So I've got to see that you did this arc from here and having the 2 arc intersections after extending that line, and then having the 2 arcs here that intersect and then drawing that line. So you got to show all of those. Mark up the picture like it asks you to, otherwise you will not get credit. And that's it for that last question.